Welcome back, everybody, and today we're going to be looking at regression analysis. This is going to be pretty much the final model that we're going to be looking at statistically. Now, this will take us to, after this, we'll be looking at chapter 25. Now, chapter 24 takes a look at multiple regression analysis. I'm not going into that, but I do want you to make sure you read that because you have to read the whole textbook. But today, with regression analysis, you have software that takes care of all of this stuff. I'm going to give you the basics of it and how to plot the line, the regression line on the graph. And then we will be finished with all of the statistical models that I think you need to be aware of. So let's go ahead today and look at regression analysis and follow up after that. Today we're going to be looking at two models, which really is not a whole lot of detail when you think about it. We're going to look at the coefficient of determination. Now, we looked during the last slide presentation at the correlation coefficient, and I forgot to include the last section of that, which deals with variance. So we're going to take a look at the variance way to determine variance, and that's through the coefficient of determination. It's a very simple, very straightforward formula. But also, too, today we're going to take a look briefly at regression analysis. Now, first of all, these are the last models that we're going to be looking at. Now, chapter 24 looks at multiple regression. If you know the basics, you'd be able to go off of that. But there's also, with regression analysis, there's software that will do this. So I'm going to just go through some of the basics in it and go into the last chapter, 25, starting tomorrow and maybe next Tuesday. And then from there, I'm going to let you just take some time and study for the rest of week 15, and we'll have our final exam. But let's go ahead and talk about the material today. The first thing we'll talk about is the coefficient of determination. Now, when you are trying to see how much variance there is in Y, as the textbook says, and I'm on page 564, the amount of variance in Y that is explained by X, you can calculate that by squaring the correlation coefficient. And really what you're doing is looking at R squared is equal to explained variance divided by total variance. So when you take a look at the table on page 23.3 on page 565, you'll see that what we have at the very end, and you can follow me in the book as well, is negative 0.635. So you can square that, and the answer will be 0.403. So about 40% of the variance in hours worked can be explained by the variance in unemployment. So you see some value in that. Now, one of the things that this will do is help us to understand how much of our score, what percentage maybe of our score is based on whatever it is that we were looking at, the variance in Y that is accounted for by knowing the value of X. Now, regression analysis. Regression analysis gives us another insight into relationships, but instead of just demonstrating or pointing out the data, regression analysis helps us to explain or understand the data. Now, as you see here, the regression equation, and you can see this also starting on page 568, is the Y, which is the continuous dependent variable, is equal to alpha, which is the y-intercept. It's the regression line that intercepts the y-axis, plus the slope of the coefficient, which is the rise over the run. In other words, the rise over the run, you're taking a look at the slope. When you look at a graph and you see that line going up or down or whatever, that's the slope. So however much y-axis or y rises, it's going to rise for every 1 unit change in the x-axis. So one has an influence over the other. So that's the formula here. And let's go ahead and take a look at some more as we take a look at the parameter estimate choices. Now, again, the slope, that's indicative of the strength and direction of the relationship. The line will either go up as it leaves the axis, y-axis, or it'll go down. Now, the alpha, which is the y-intercept, is a fixed point that is considered a constant. How much y can exist without x? Now, you'll see this in a few slides, and it's in your textbook also, an example of it. So don't really worry yourself at this point about what we're talking about. Standardized regression coefficient. It's the estimated coefficient of the strength of relationships between the independent and dependent variables. And again, the range is -1 to 1. So the stronger it is, the more positive up to 1 you're going to have. Now, what do we mean by this? Well, take a look at page 568 at the bottom, and you have here in Exhibit 23.5, suppose a researcher was interested in how much space was allocated to a specific snack food on the shelf and how it related to sales. 15 observations are taken from 15 different stores. The upper line represents a typical distance showing shelf space measured in centimeters. The lower line is the same distance shown in miles. Now, the top frame shows hypothetical regression results if the independent variable is measured in centimeters. The bottom frame shows the very same results if the independent variable is measured in miles. Now, you have the same measurement, but look at how they are played out. The parameter coefficients do not seem comparable. So when you're doing this, if you wanted to measure in feet, centimeters, miles, inches, whatever, you may have different parameters. So this is where the standardized regression coefficient comes into play. And you see that here on page 569. And they explain that in the formula would be y hat, which is the standardized regression coefficient. You have y hat is equal to 0. So the y-intercept term, as they say here in page 569, is always 0 plus 0.16. And that's going to be the independent variable. So they've given you some more symbols for it here below it. And you also have raw regression estimates. Let me see if they show that here. Yeah, in the next slide, we see raw estimation estimates. And for the purpose of what we were just looking at, the shelf space, the y hat is equal to 22, so they're using the centimeters plus 0.7. We found that in 23.5 multiplied by 14. So if we are estimating 14 centimeters of shelf space, then this is going to be the outcome 23.0, which would be the amount of snacks that we can sell with that amount of space. So it's not very difficult, but it does require you are estimating and being able to eliminate errors in that estimation will help you, and using these formulas will help also. Now, this is the way that they have it in the textbook, and if you turn to page 570, you'll see that you have dealers and dealer sales volume and building permits. So they want to know if there's going to be a difference in the number of building permits and if that will influence dealer sales. So the dependent variable will be sales volume. The independent variable will be building permits. So we have here at the Y bar, if you look up here on the Y axis, you have 100, and that's the Y bar, that's the mean, 99.8. And that's just going from the dealer sales volume and getting the mean of that, and you can plot that out. And then what they do is just take each dealer. As you can see here, all of these little dots along the way on this graph, these are the sales that the dealers were able uh, to have. And then once you do that, you see here the best fit line are knocking out the pins. So really what you're trying to do here is take a line, and in the midst of all of that, draw your line in the middle of it so that it is knocking out, or it is covering the majority of those actual sales. So it's not very difficult, and then they give you the y-intercept and raw parameter slope coefficient. Again, we're not going into that because it's going to be too detailed, but really once you plot out, you have sales on the y-axis, you have building permits on the x-axis, you line those out, number them out, find the mean, which is 99.8 in this case, and then just plot all of those sales on the graph and then line right down the middle of it all, and that will give you the best fit or knocking out the pins. Today we looked at regression analysis, and we saw how we can actually look at cause and effect relationships, whereas the other models just showed us the data. Regression analysis helps us to understand how much X and Y are dependent upon each other. Well, that's all we have for today. Tomorrow we'll be in chapter 25. Now again, we're not going to go into chapter 24, but I want you to read it. But we will go into chapter 25 tomorrow, and I'll probably finish it up on Tuesday and let you have the rest of next week to study and get all of your things in for your class. So take care, have a good day, and we'll see you next time.